This was the beginning of the subject called functional analysis, where you turn around and view, instead of f of x, you turn this around as x of f. And then, for particular x, you have many f's. And you can work with the functions as being points in this formulation. Okay? Just a little backwards than we're used to. Explain that to the calculus 2 class. Okay. So we have all that stuff. All right. Any questions on that? If we have a partition, what's a Riemann partition? It's a set of things that look like this. There's a C, when you see Ci, Xi, minus 1, Xi. So that's a subinterval and a point in the sub. Like this. Could be one of the endpoints, but not necessarily. And then I is from a set of positive numbers, say 1 to n, right? Just that on. So it's a finite collection of these things. A tag point and a subinterval in which the tag point exists. Okay. As we said before, for a Cauchy partition, the tag point is irrelevant because it's always the left endpoint of the constituent division. Okay. Given f, define, say, on AB, and alpha defined on AB. So far, no conditions. We're going to place some stringent conditions on alpha in a little bit. A Stieltjes sum is something of the following form. It's the sum over the partition. In other words, all the indices that are covered. Right? I won't be right now. And I take the function and evaluate it at Ci. And then I take the alpha function and evaluate it at Xi and subtract the evaluation of alpha at Xi minus 1. Okay? Let's give this a name. This is a let's just call it this. There's a specific f, a specific alpha, and a specific partition. So for shorthand, that'll be okay. All right. Where's the generality here? This alpha function. Think of it as a weight on the x-axis. If alpha of x equals x, then what happens is we have a sum over the partition Fci Xi minus Xi minus 1. That's a Riemann sum. So in the special case, when the weighting function, alpha is the weight, and this is the function to be integrated. With respect to that weight. So if alpha is just x, it devolves to a conventional Riemann sum. if by the way, very often this is written delta alpha sub I. Okay? So if the limit as the norm of the partition goes to 0 of S F alpha P equals I, we say that F is Stieltjes integrable. And the Riemann Stieltjes integral A B F B alpha equals I. And once again, if alpha is X, then it's just called Riemann. Stieltjes didn't live very long. He died in 1940 in the late part of the 19th century, operating maybe 30 or 40 years after Riemann. And this was an improvement in terms of generality of the Riemann integral, which was propounded about 1854. So Stieltjes was doing this in the 1880s and early 1890s. So special case, if alpha is X, then you write sum F E, and that's just a Riemann sum. Okay? Now, remember it happened with the Cauchy integral that if partitions get fine enough, the sums with respect to sufficiently fine partitions all were pretty close. That's the small mesh lemma. If you go back to that sheet that I published there, the small mesh lemma. Let's try to establish that for the Riemann Stieltjes situation. But first, let's get some practice just doing stuff now. Let's see if we can integrate from A to B, Riemann Stieltjes sense. 1 B alpha. What's that? The constant 1 function integrated with respect to an arbitrary weighting function. Well, what would an appropriate Stieltjes sum look like? The F of Ci would just be 1, right? Then you'd have a delta alpha I, and you'd just be summing those up over the partition, right? The delta alpha I sum. That's right. That's a telescoping sum, you know. So you get alpha of B minus alpha of A. You know, that's the total weight of the interval. Okay, I think you like that. Everyone okay with that? So we think this is alpha of B minus alpha of A. What is this if alpha is a constant weight? Don't think of alpha as a density. Think of it as the cumulative weight from the origin. Right? It's not a density. It's well, you know, like probability density function. It's not a density. It's not one of those. It's like a cumulative distribution.
Oh, that's a Q1.
You can see that. What's the delta alpha? If alpha is constant, what's delta alpha every time? Zero. So it really doesn't matter what the function is. You multiply it by no weight. Right? So that's 0. what, I was kind of the page, here, we'll stay here.